Hi, and welcome to Class 13 on the instantiation syllogism. The instantiation syllogism is the mirror image of inductive generalization, and between the two of them, you get the two main forms of argument regarding generalizations. Okay. So, to review, inductive generalization happened when you have arguments that move from particulars to generalizations. So you have a bunch of individual experiences with, for instance, a white swan. Here's a white swan, here's a white swan, here's a white swan, and then you draw the generalization, all swans are white. So when you write an argument, an inductive generalization in standard form, it's going to look like this. In a sample of 100 swans, 100% have been white. Therefore, all swans everywhere are white. So you are moving from a quantified categorical statement about a sample to a quantified categorical statement about an entire population. This argument is inductive, right? Because you are going past the existing evidence to make a bigger claim. So instantiation, inductive generalization goes up to a generalization. Instantiation syllogism goes down from a generalization to a particular. So you might start out saying Odette is all swans are white, and then say therefore Odette the swan is probably white. So when you put the argument in standard form, it's going to look like this. All swans are white. Odette is a swan. Therefore, Odette is white. It actually looks exactly like the all men are mortal or all people are mortal argument that we looked at a while back. So the exercise coming up, and the key skill here, is to learn to tell the difference between inductive generalizations, when are you going up, and instantiation syllogism, when are you going down. So let me just run through some more examples. Okay, so imagine an argument about a political poll. So in a sample of 3,000 likely voters, 57% said they would vote for Biden. Therefore, in the population of actual voters, 57%, plus or minus 3%, will vote for Biden. Now take a second. Is this an inductive generalization or an instantiation syllogism? Are you going up to a generalization or down to a particular? So the answer is that it's an inductive generalization, because we're moving from a sample of 3,000 voters to the population of all actual voters, right? The people who actually wind up voting. Now look at this one. 95% of Americans own a cell phone. Clint Yoder is an American. Clint Yoder owns a cell phone. Probably. You can be 95% sure. Is this an inductive generalization or an instantiation syllogism? It's instantiation syllogism. You're going down to a particular. All right, let's talk about precise definitions here. So an inductive generalization is an argument with a quantified categorical statement in the conclusion and a quantified categorical statement about a sample of that population in the premises. So you are moving from a sample to a population. And the argument scheme for that looks like this. In the sample, X% of Fs are G. Therefore, in the whole population, X% of Fs are G. Right? That's from last time. Now let's look at the flip side for this time. Instantiation syllogism is an argument that has a quantified categorical statement in the premises and a statement about a member of that category in the conclusion. So you're reasoning from a generalization to a particular. And the argumentation scheme for instantiation syllogism would look like this. X% of F's are G. This is an F, therefore this is a G. Right? So now let's look at our examples again and see if you can just to focus on how instantiation syllogism is different than inductive generalization. So you have this argument. This is our inductive generalization. In a sample of 100 swans, 100% have been white. Therefore, in the whole population of swans everywhere, 100% are white. That's an inductive generalization. Going the other direction, all swans are white, Odette is a swan, Odette is white. That's the instantiation syllogism. So look at how these are different. In the inductive generalization, the quantified categorical statement about the biggest group is in the conclusion, right? So you've got a big quantified categorical statement as your conclusion. In instantiation syllogism, there's only one quantified categorical statement, and it's in the premises, right? So if you want to know which kind of argument you're looking at, look to see where the quantified categorical statement is. If you've got a quantified categorical statement in the premises but not the conclusion, then it is instantiation syllogism. If you've got them in both premise and conclusion, and the conclusion is about a larger group than the premises, then it's inductive generalization. All right, so let's look at some more of the examples we looked at. In a sample of 3,000 likely voters, 57% said they would vote for Biden. Therefore, in the population of all actual voters, 57% plus or minus 3% will vote for Biden, right? And then our other example was 95% of Americans own a cell phone. Clint Yoder is an American, therefore Clint Yoder owns a cell phone. The first was inductive generalization, the second was instantiation syllogism. And look, in the first one, the quantified categorical statement about the biggest group is in the conclusion. And in the second one, the only quantified categorical statement in the whole thing is in the premises. Okay, let's look at another crucial difference between inductive generalization and instantiation syllogism. So here are our two previous examples of inductive generalization. In a sample of 3,000 likely voters, 57% said that we have got the Biden example and we've got the Swans example. The thing to note here is that in both cases, the argument is inductive. That's why we call it an inductive generalization. It goes beyond the information given. In one example, in the first example, you're going from a group information about 3,000 people to information about all people who actually wind up voting. Goes beyond the information given. In the second example, it also goes beyond the information given. The information given is about 100 swans, and then you draw a conclusion about all swans everywhere. So the lesson here that's important is that inductive generalization is always inductive. That's why it's called that. But instantiation syllogism works differently. So here our two arguments were 95% of Americans own a cell phone and all swans are white. So one starts with a premise about 95% of the population, and the other starts with the premise about every member of the population. In this case, the first argument is inductive. The conclusion is not certain. given the amount of information you have, you are 95% certain of the conclusion. The second argument is deductive. The conclusion is certain. In fact, this has the exact same form as the standard example of a valid argument that we gave beforehand. So that we gave when we first introduced valid arguments. All people are mortal. Socrates is a person, therefore Socrates is mortal, right? So example 1 is inductive. Example 2 is deductive. Example 1 is strong, if assuming that we've got all the information here. Example 2 is valid, right? So the lesson is that instantiation syllogism can be deductive if the quantifier in the premises is all. Once you have an all, you've moved into that realm of rigid rules where validity is possible. All right. So we've got two styles of argument, and we've got two specialized versions of standard form, two specialized versions of the argumentation scheme to put them in. So also with any kind of argument, you have certain critical questions, right? So let's go over those. We said that critical questions were questions that you should ask once you have analyzed an argument by putting it in standard form. And some critical questions can be asked of any argument, and others only go with certain forms of argument. So to remind ourselves, the critical questions that go with any argument are the premises true, or at least plausible? Do the premises support the conclusion enough given the circumstances? And has any relevant information been omitted from the premises? We can always ask these questions, and we always should. In the previous class, we saw that if you are dealing with an inductive generalization, there are specific versions of the second question that you can ask. You need to ask, is the sample large enough? And is the sample representative? So these are the sub-questions that are specifically for inductive generalization. The same thing happens with instantiation syllogism, right? But this time we've got a specific question that we want to ask that's a version of question 3. Has any relevant information been omitted from the premises? And that question is this a typical member of the category? So let's go back to our Clint Yoder example. We began by saying 95% of Americans own a cell phone. And since Clint Yoder is an American, Clint Yoder must own is 95% likely to own a cell phone. Well, it changes everything if I add a piece of information. Clint Yoder is actually an Amish farmer. Now, the Amish aren't supposed to use technology. They have different rules depending upon which community they're in. They set their own rules by community. But as a general rule, they don't like to own cell phones. It's considered vanity. So this extra piece of information that was not in the premises makes the changes your opinion of the argument. You can no longer be 95% sure that Clint Yoder owns a cell phone, right? So with each argument scheme, there are critical questions that you can ask, and when you get the wrong answer for those questions, when it turns out the argument is bad, you generally say that a fallacy is being committed. So here what we have is what's called the fallacy of suppressed evidence. It's a fallacy, and that just means you left out a crucial detail that changes everything, right? And lying behind that is a general principle of reasoning, the principle of total evidence. This is the rule that says you should take into account everything you know about a particular when making inferences about it.